everyone. Good morning, good afternoon, and good evening. It's my honor to welcome you all to this webinar. My name is Cassie Wang from CIOE, China International Optical Electronic Exposition. I'm your moderator of this webinar. Today, we'll have Daniel Lee, Assistant General Manager of Optizone Technology, share with us the importance of fiber optical cable in industrial CW laser. It'll take 25 minutes, followed by a 5-minute Q&A session. So hope you enjoy the webinar and feel free to write down your questions in the Q&A window. Let's welcome Daniel.
For those who are in the US and Canada, and good morning to you. And for those people who are in the Asia, good afternoon. My name is Daniel Lee from Optizone. And today the topic I'm going to present is the importance of fiber optic cable in industrial CW laser. First, let's take a look at the contents. Before we really go into the fiber optical cable, because fiber optical cable are meant for industrial laser. So let's take a look at the development of the global lasers and also the China industrial lasers. So first, we are talking about the development. And then we'll go a little bit more into the China industrial lasers by looking at the application, followed by the different type of fiber optical cable, the key factors which affect the fiber optical cable, the reliability test that is required, and the production line and facility, which is just as important in making good fiber optical cable before we go into the conclusion. Okay, let's take a look at the development of the global versus China, the industrial laser market. According to the data released by Laser Focus World, global laser market in 2020 was US 16.5 billion. And out of this, China laser market account for about 10.91 billion, which is like 66.12% of the global laser market. And from this 16.5 billion global laser market in 2020, if we look specifically at the industrial laser market, it was like 5.157 billion. So literally means that the industrial laser market account for 31% of the global laser market. And from this data shown, the latest market share for industrial laser market, more than 50% is fiber lasers, back from 2018, 2019 to 2020. And in fact, actually last year, 2021, it's just that this data does not show the 2021. So from the above data, although the global industrial laser market, we can see that it is accounting for like 5.157 billion over the entire laser market of 16.5 billion. So to some of you, it may seem that this figure is not so, potentially promising, but yet if we analyze the market trend over the recent years, it will give us a different deduction. So first, maybe we can look into China laser market because China laser market covers like 66% of the global laser market. So inevitably, we should consider the scale and the rapid growth of China market. Okay, further data released from Laser Focus World. It shows that China laser market, it has been growing for the past 5 years. Yeah, in fact, more than 5 years, 6 years. So global laser market continue to rise. China laser market also continue to rise in proportion. If you look at this data, back in 2017, the China laser market is like 6.95 billion. And then if you look into 2020, it becomes 10.91. And then the 2021 is 12.68. Although over here, this data is published end of last year, so it does not, it actually show an estimate figure, but in actual fact, it is already over. So 2021, yes, is like, 13 billion. So this figure is right. And it has been growing for over 5 years, in fact, 6 years. So at present, China has a complete laser industrial chain. It's from parts to equipment, from lasers to system. China just, have a very huge end user market. So the global laser market, which is 5.157 billion, more than half are fiber lasers, and they are mainly produced in China. Whether it is for the lasers they produce in China is for domestic or for export, they are produced in China. But then, when we look at the high-end part of it, the high-end manufacturing, China is still kind of like, a weak link in the China manufacturing industry. We know that more than 90% of the worldwide low-power industrial lasers are from China. In fact, the data from the source from our data shows 99%. But then, from medium and high power, it's only like 56%. So this means that the potential scale of high power lasers is really still very big in China. So take a look at application now. Again, since this topic is talking about the CW laser, because we are talking about fiber optic cable, which is used for CW laser application mainly. So we will just focus a little bit more on the CW laser. So in material processing, first, we can see the industrial lasers, we can divide it into different kind of functions. We have laser cutting, we have laser welding, marking, semiconductor, precision machining, many other fields, And then out of this, cutting, at this moment, cutting is still accounting for 40%. Welding account for 14%, marking account for 13%, semiconductor 12%, and others. So from application point of view, material processing, we are talking about laser cutting, welding, and all that. And then actually there are more emerging applications, such as laser cleaning, 3D printing, laser radar, laser medical chromatography, 3D sensing, laser display, laser sensing, many more. So this new application, it promotes the rapid development of the laser industry, especially in automobile, in consumer industry too. So this is one example of an application of an industrial laser in the OLED. So we are talking about in the OLED laser equipment divided into 3 terminal, the BP terminal, which is mainly used in laser analyzing. And then we are talking about the EL end, which is usually for laser cutting purpose. And then the module end, which is also for laser cutting. These are for OLED. And then we have application on industrial laser, which is for the lithium battery, whether it is the core or the module. We call it the pack process. Again, we are talking about big potential and large increasing figure over the next 3 to 5 years, especially in this lithium battery application. And we have industrial lasers, especially for smartphone application. In smartphone, we are talking about laser marking, cutting, welding, others, but of course, industrial laser for smartphone are usually low power lasers. And on the other hand, if we are talking about application of industrial laser in automobile, this is definitely for high power lasers. So high power lasers are extensively used in automotive. We are talking about China automotive manufacturing equipment. The market size is like 150 billion. And in fact, it's growing. It's still growing. So what are the different types of fiber optical cable that can be extensively used in so many different applications? Well, when we look at fiber optical cable, there are many types. But then more importantly is we should try to understand what is the role of these cables in industrial CW laser. How important are these cables in industrial CW lasers? This cable may not seem significant to some of you, in the industry, but in actual fact, the importance of these cables, the choosing of what kind of cable to be used in the fiber laser, this is really important and cannot be ignored. So what are the different types? Let's take a look. Okay, this is a schematic diagram of a typical CW laser. As we can see from the right side, of course, the output will be a fiber optical cable, end cap, or we call it. A typical structure like this, a CW laser, of course, from the pump diode, you go to the pump combiner, and then the FPG active fiber, and go to the cladding power stripper, the CPS, followed by the pump signal combiner and all that. Well, my company Optizone, we make all kinds of components. Typically, all these components inside we make. But now, today, we are talking about the output and the fiber optical cable. So what are the types? So we have the QCS, which is air-cooled. The connectorization, of course, is not exactly the same as a QBH because it's air-cooled. But one advantage is that QCS means that there is a collimating lens inside, which means that the light are collimated. So that is why we are talking about a beam diameter, maybe like 1 or even up to 20 mm. Air-cooled, QCS is air-cooled. So of course the power is less than 800 watt, usually. We are talking about QBH, which is water-cooled. So another type of connectorization. Usually the power is ranging from 800 watt to up to 20 kilowatt, with all different kind of fibers being used. And of course, all kinds of wavelength, even from visible light like 445 to 530, even up to 1 micron for industrial purpose, even up to 1.5 micron or even 2 micron. And then we have the QD, which is also water-cooled. But then this is usually for over 10 kilowatt, even up to 30 kilowatt. And then we have the RQB, which is also air-cooled, but then RQB is not is without a collimator, so it does not have a collimating lens, so it cannot have collimated light. Again, this is less than 800 watt because it's air-cooled. If some of you want to choose a QBH, which is at the same time functioning of QBH, but then you do not actually care too much of the connectorization, you can actually choose the LBC. We call it a large beam collimator, because this collimator, it means it is collimated with the collimated lens, and since it's water cooled, it can be like 2 kilowatt. Of course, for some application which is really for using low power, like less than 200 watt, like 150 watt, you can choose a SMA 905 cable. You can also choose a D80 cable, which is ranging like 300 watt or less. Over here, I'm showing here a fiber optical cable, which is ultra-fast laser. So this means that fiber optical cable, it does not necessarily mean that it is for CW. It can be for ultra-fast, which is pulse application. So what are the key factors which affect fiber optical cable? Well, actually, we are talking about from the materials and to the process of making a fiber optical cable. That are the key factors. So first of all, the choosing of the quartz rod. Well, it may seem simple, but then quartz rods, the quality of a quartz rod, it plays a very, very important part. The first step of making a fiber optical cable, you have to take care of what kind of quality your quartz rod is. So the polishing end at the quartz end, the polishing quartz end, the AR coating, the way you do your inspection, which is definitely necessary, for any possible dental spots or even black spots or even uneven surface, And the beam quality. Over here, there's a chart talking about the AR coating. So it is from 1050 to 1100. It is not specific at a certain wavelength only. It is for a whole range for industrial purpose. But then, more importantly, is the beam quality, the M squared. So it is determined by the beam ellipticity. It is determined by the beam pointing accuracy, and of course, the beam distribution uniform, whether it is stable. It plays an important part of having good beam quality. This is a typical example of beam profile from 2400 micron fiber. So a single mode, and the chart here just simply show a perfect beam profile for this kind of single mode fiber. And then this is for multi-mode, a typical example of 100, 120, 360 triple clear fiber. A multi-beam profile with very uniform energy distribution. And then we have the CPS. Some of them choose to have a CPS incorporated with the cables. It is not a problem. Of course, some of them may not choose to have a CPS incorporating. Still, the importance of a CPS, so this is a structure, internal structure, how a QPH work, for water cool type. And even the choosing of window protection cap, whether you are choosing protection cap which is from IPG or Optoscan or some others, how you match this protection cap, how can it be compatible with your cable? Again, this is not just a small issue. It is really important. Production line and facility. Clean room. Making a fiber optical cable, it may seem easy. Some of them may think that it can be done easily. In actual fact, besides talking about those materials, those inspections that you need to do just now, when we are talking about, you need to take care of the classroom, clean room environment. We are talking about class 1000. You can have class 10,000 if you are talking about mechanical kind of testing, or even the fiber coiling, or even cutting. But if you are talking about the assembly, you're talking about the splicing and all that, you have to have class 1000. The cross-flow soldering process, again, this is a key factor. Even simple things like fiber coiling or cutting or measuring, because fiber optical cable typically is usually like 20 meters long, it's really long. So you need to have automation, because you can't just do it manually. It will not be consistent. So simple thing like this, you still need to have automation in order to perfect the fiber optic cable. And since different fiber optical cable use different fiber, so the first step in making a cable is the fusion splicer. Using the fusion splicer to splice different thickness, cladding, diameter, you have to have different splicer and different cutter. You choose an inappropriate splicer or cutter, it will not just work. And of course, beam profile. You test the beam profile 3 times. It's not just at the assembly part. You test it even when just after you do your splicing. Reliability test. This is a typical reliability test conductor for cables. Actually, number 1 to 5, it is more like in accordance with telco standard, the telecom standard, because in the industrial, there's no industrial specification for cables at this moment, only recently. So for a 1 to 5, most of the people will accept, will adopt the telco standard, the telecom standard. So we're talking about dam heat, which is high temperature test. We're talking about the cycling test, vibration, drop test, impact test. But then number 6, 7, 8, it is only for fiber optical cable. For example, the power test, forward, back reflection power, the waterproof test, the dust test, IP6X, we call it dust-proof test. So in conclusion, over the past 5 years, global laser market continued to raise, China laser market also continued to raise in proportion. So based on the data source that we are given, we have been reading it, we can actually make a deduction that there will be an average like 10 to 15% increase annually. So in 2020, the global laser market is 16.5 billion, right? And China laser market is 10.91. And it's going to increase 10 to 15% annually for the next 5 years, maybe. So you can calculate the math. For global industrial laser market, it's account for more than 30% of the global laser market. So from data source shown again, we can make a deduction. There will be an increase of like a continued increase, like 50 to 60% in the next 2-3 years. So back in 2020, the industrial laser market in China is, the global laser industrial market is 5.157 billion. and it's going to increase for the next 2-3 years by 50 to 60%. Okay, at present, more than half of the global industrial market are fiber lasers. Again, when we look at source given, fiber laser will gradually replace solid state laser, will gradually replace gas laser, semiconductor, and all other lasers. So in the next 3 to 5 years, 70 to 80%. It's not just half. Now China is producing 60% of fiber laser. 90%, more than 9% are low power, 56% are medium and high power, and we can expect China will produce like 80% in the next 3 to 5 years for the global market. So just now we mentioned how you should choose a fiber optical cable, the selection even from the material like coarse rods, the testing of the beam quality, the selection of the window protection care, and you need to take care of the environment, which is definitely a class 1000. But over here, of course, I mentioned class 10,000 because there are some mechanical tests, fiber coiling and all that can be done in class 10,000. And of course, choosing the fusion splicer is extremely important. It's not a small issue because if you choose the appropriate one, there will be no way you can make good fiber optical cable. Automation, semi-automation is just as important, even for simple work like fiber coiling or cutting. And of course, lastly, reliability tests have to be done. And it is an ongoing process. It's not a one-time test. Okay, so this ends my presentation. And I'll be happy if any one of you have questions to ask. I will try to answer on the spot. Thank you.
Thank you, Daniel.
Yeah.
And we have some, and we will move to the Q&A session. Actually, we have some several questions in there.
Okay.
Okay, the first one is, any needs for multi-layer concentric optical fiber for China market?
Let me see. Wait.
Yeah, you also can check the question in the Q&A window.
Oh, actually, I'm checking. What's the question again?
The first one is the any needs for multi-layer concentric optical fiber for China market.
The
first
multi-layer concentric optical fiber for China market. Frankly, actually, I'm not sure. Because at present, concentric optical fiber is not commonly used in any known industries. Whether it is in fiber laser industry or any others, well, not of I know, maybe, then again, I think there are some R&D institute that I know, they are trying to use not this kind of concentric multi-layers concentric optical fiber, but they are trying to use like circular fiber, square spot kind of optical fiber for some of their projects. But still, these are in the R&D, so that means they are like in a laboratory stage. Not of I know that is already available in the market with known products using this kind of concentric optical fiber.
Okay, so the next one is, what impact the fiber optic as in 5G?
Okay, if we are talking about 5G, fiber optic in 5G, the impact, I presume that this is not just talking about the industrial laser market, definitely not talking about just the fiber optical cable, right? Because we are talking about 5G, it's totally another different industry. So, first of all, I think it is necessary to know that when we are talking about, let's talk about just the passive optical device, because we should talk about just passive, So let me see. First, 5G is evolving from optical network, right? And considering all these advancements in technology over the past 10 or 20 years, optical network, keep expanding in market size and has been entering a new era. So more and more applications are being explored, which involves 5G. Fiber optic is like a backbone for every system, subsystem, even module. So obviously, there's big impact on 5G. In order to really know how big is the impact, fiber optic, because when you mention fiber optic, it's like too general, a very broad term. I think it will be necessary to really, what we can do is we can actually look at a lot of data and sources available for 5G. And from there, then there will be a lot of data, different data that talk about different kind of things that is in the 5G. For example, you are talking about the system integration, or for example, you're talking about just devices, modules level. Then we will know what kind of impact in different, different fields. Yeah.
Okay, thank you. And the next one is, what's the new tech for cooling without water for high power CW laser? I think it's more.
Okay, this is definitely talking about the fiber optic cable because you mentioned the CW laser. Okay.
Yeah.
Currently, what's available in the market, or even for my company, we could only produce the cable, which is air cooled, that means without water, which is less than 1 kilowatt, in fact, like 800 watt, So what we see available in the market, I mean, whether it is the materials, the raw materials, that is making the fiber optic cable, or whether it is the process itself of making the fiber optic cable, we do not see any way that we can have cables that is air cooled, that means without water, that can sustain even 1 kilowatt or even above 1 kilowatt. So there is no way. Okay, so first of all, we must know that this is definitely a fact, that we cannot be ignored. Okay, so you say, what's the new tech for cooling without water?
Yeah.
Well, I don't know. So the fact means that there is no way to have very high power, like over 1 kilowatt, if the cable is without water. Okay, so the only possible way, I think it can, it's still possible, is if you have an external cooling system, a water cooling system, that kind of cooling system, external one, which you can help in doing the cooling effect. Like for example, currently the market is getting very hot on the handheld welding, the handheld welding application, which we are also doing, actually, my company. So this handheld welding, it has actually, the actual application is they have a external water cooling system. So in this case, that means you actually did not have to worry about whether your power is less than 1 kilowatt, because it cannot be higher because it's air cooled, it's without water. But you have an external water system, then it's possible. Yeah.
Okay. And we also have questions from Finzi. What's the market change of passive optical device?
The market trend. So then again, when we are talking about the market trend of passive optical device, we are not just talking about the fiber optical cable, right?
Yeah.
When we say passive device for the market trend, first we must know that there are a lot of different market in different industries. They are using passive device. I mean, we are not just talking about the fiber laser industrial, the industrial type. We are talking about even in optical network, in sensing, in LiDAR, in all kinds, quantum technology, communication and all that. So they are using passive device. So when you say market trend, first, we need to know exactly what market trends in different industries. There are a lot of data, articles available in the market, in website and anywhere, that you can actually, retrieve and actually analyze. I mean, there are a lot of data that talk about, for example, OCT, medical industry, that use, of course, they use a passive device, for their OCT system. There are a lot of data and articles that talk about LiDAR, so you can actually look at all these data, because first of all, you need to have different industries. You cannot just look at the passive device, but you have to look at different industries to know the market trend. Of course, LiDAR, for example, is probably, if you compare to right now the industrial lasers market, LiDAR is probably 10% of market size. OCT actually is almost the same size as industrial laser, but of course not in China. Actually, China is still kind of, they need a lot of time to catch up, if you're talking about biomedical or like OCT, yeah.
Okay, thank you. And one more question from Eileen. Can hollow fiber be used in an optical cable for optical energy transmission up to 10 of kilowatts?
Well, at present, hollow fiber is typically used in ultra-fast laser, as I know. So in terms of the ultra-fast laser application, right now, currently, there's no necessity to have, a very high kind of power, optical energy transmission up to like tens of kilowatt. Right now, there's no available in the market because the fact is they do not really need such high power in ultra-fast, laser. So unless the usage of these ultra-fast continue to explore and much higher power is required for particular application. Otherwise, yes, I don't see there's a need for such kind of high power, tens of kilowatt. It's probably I won't see it coming in the next 2 years, probably no, not so high.
Okay, and we also have questions from Yang. What's the most commonly used thermal management material in high power industrial laser?
This is kind of complicated and actually involve a little bit more about not just talking about the material, but the process in more details. In order to say that, I think more like you have to be answered in more in writing, and also because the fact is my company Optizone, we make this kind of optical cable. We have to be confidential in some information release. So I will need to reply probably in writing, but it will be not just 1 or 2 lines.
Okay. And the last one is, how do you select fibers for high power cables?
Well, actually, in high power cables, this kind of fiber optical cables, it is not up to us who make the cables to select the fibers. Actually, it depends very much on the fiber laser manufacturer themselves, the people who design and make the fiber laser. So what active fiber they are using? You have to match, because we make the cable, we have to match with their fiber laser. So if they are using a 20 micron core fiber, be it whether it is from Newfern or Coreactive or whoever, if they are using a 20 micron core size, of course we have to use a 20 micron core size. Of course, we can choose not to be. If they are using from Newfern, it's not necessary that we must use our passive fiber to make the cable also from Newfern. Not exactly necessary, but still we have to match according to the core size and even the cladding diameter. We have to match. But the selection of the fiber is not depending on the people who make the cables like us. It's depending on the fiber laser manufacturer.
Okay, got it. And in terms of the in the interest of time, that's I think that's all for today's webinar. And thank you for everyone. Hope you really enjoy it. And if you have more questions or any inquiries, please feel free to contact us.
Okay.
Yeah, thank
Thanks,
you, Daniel.
everyone.
Really
Yep.
appreciate your answers. And you can also write the answers in the Q&A window if you would like to.
Okay. Yeah. Yeah. Thank you.
Yeah, and CIOE 2022 will be held on September 7 to 9 at Shenzhen World Exhibition and Convention Center. So please register as our visitor by scanning the QR code on the slide. You'll find thousands of optical electronics companies like Optizone Technology at CIOE. See you in September in China. Take care and have a nice day. Bye.
Okay.
Thank you, Daniel.
Yep.
Bye.
Thank you. Bye.